We are 250 miles above the Earth, about to board the International Space Station. Life is very different aboard the station. Up here, we experience a sunset every 90 minutes. With each orbit, we can see the world's sprawling cities. Occasionally, a delightful natural light appears to dance around our spacecraft. A popular viewing destination is far up north, in frigid Yellowknife, Canada. Leaving the warmth of his teepee, astrophotographer Kwon-Oh Chul used his special camera to record these northern lights. He is not alone. The group is outside tonight, enchanted by this natural spectacle. The impression of this striking display may touch your heart and stay with you forever. It is easy to appreciate how these northern lights have inspired centuries of folklore. Some indigenous peoples of North America believed that these glowing veils were the spirits of departed children, ancestors, and warriors. They called the Northern Lights Dance of the Spirits. From one generation to the next, they shared their belief that the happier the spirits were, the brighter the skies would shine. A long time ago, the Finnish people called the Northern Lights foxfire, believing that an Arctic fox swept its long tail across the snow, sending streams of sparkling snowflakes up into the sky, creating the Northern Lights. The Northern Lights dance above your head in polar regions. But as we travel farther to the south, the lower part of the aurora, which glows green, becomes hidden beneath the horizon. Only the very top part of the aurora's glowing red is visible. In medieval times, the peasants trembled with fear, believing that the strange light was an omen of war. Or perhaps the heavenly glow was a message from God. The great Italian scientist Galileo Galilei called the mysterious northern lights aurora, naming them after the Roman goddess of dawn. According to Roman mythology, at every dawn before sunrise, the goddess Aurora brings light to the world. We still use Galileo's Latin name for the phenomenon, Aurora Borealis, dawn of the north, because the light shining in the northern sky resembles a reddish dawn. The sun accounts for more than 99% of the total mass of our solar system. Its gravity compresses the gas at its core, triggering the tremendous power of nuclear fusion. Most of this energy is released as heat and light. Periodically, some of the energy is released in gigantic eruptions of high-energy particles. Light from the sun travels to Earth in 8.5 minutes. The slower-moving solar wind particles take 2 to 4 days to reach as far as Earth. Some particles move along the magnetic field lines toward the polar regions. When these particles collide with molecules in the upper atmosphere, they release the light of aurora. Sometimes particles collect in Earth's magnetic field opposite the sun, then rush back into the atmosphere. This is called an auroral substorm and causes spectacular auroral displays. The color of auroras change depending on the energy of the particles and what kind of molecules they interact with. At the top of the atmosphere, some particles collide with atoms of oxygen, which then emit red light. In the lower atmosphere, oxygen molecules excited by collisions with solar wind particles generate green light, which is the most common auroral color. During the most powerful auroral storms, the nitrogen molecules in the air closer to Earth radiate in both red and blue light. These high-energy particle storms produce the most sensational colors,